Hello and welcome back. Today we're going to be talking about standard deviation. So this is mostly going to be a conceptual video today. It's not going to be too math heavy. I want to talk about standard deviation and like what it exactly is when we talk about it. Standard deviation is going to be something talked about a lot in a statistics course. So I just want to make sure we understand what we're talking about. Okay, so say we have two classes. Class A, 5 students score a 70. Class B, we have students score 50, 60, 70, 80, and 90. Now, if you took the average for both classes, they would both have an average of 70. But do they tell the same story? All right, some vocabulary to go over before we begin. The mean or the average is the center of the data. Variation is how spread out the data are. Deviation is the distance between a value and the mean. And then what we're going to focus on, standard deviation, is the typical distance that data values are from the mean. You could think of it as the average distance any given point is from the mean. Okay. Standard deviation tells us how spread out the data set is. A small standard deviation, values are clustered near the mean. And a large standard deviation, values are spread further from the mean. The average alone tells us the center, and the standard deviation tells us the consistency. Okay, so let's go back to the example we started with and let's visualize it. So here we have a dot plot of both classes. Class A, we could see 5 points at 70. In Class B, we have 1 point at 50, 60, 70, 80, and 90. Okay, so Class A has a low standard deviation. All of the points are exactly at the mean. There is no standard deviation. They're all just there. Where Class B, so our means are the same for both, but because Class B has points going all around the mean, it has a higher standard deviation. The points are more spread from the mean. Okay. Here's an example. Okay, so we have our data set 4, 5, 5, 6, and 10, and this is data elements 1, 2, 3, 4, and 5. So we take the mean, add them all up, 4 plus 5 plus 5 plus 6 plus 10, divided by 5 because there's 5 elements or observations. We get 30 over 5, and our mean is 6. So let's examine each individual point. 4 is 2 away from the mean, and I think the best way to visualize this is with a number line. I'm just going to draw one out here really quick so we can take a look. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to label every other one. 4, 6, 8, 10. Our mean is 6, so I'm going to put that there. Okay, so 4 is 2 away from the mean, 1, 2. 5 is 1 away from the mean, 1. Another 5, 6 is the mean here, it's at the mean. And then 10 is 4 away from the mean, 1, 2, 3, 4. So you could say that each one of these, this is how far it deviates from the mean. 4 deviates by 2, 5 deviate by 1, 6 does not deviate, and 10 deviates by 4. Let's get rid of this. Okay. Listed above is each individual value's distance from the mean. Standard deviation will tell us the typical distance from the mean, or the average distance from the mean. We don't want to call it the average distance from the mean because that's saying the average distance from the average, which gets a little wordy. So we say typical instead. Because one value is much further away from the mean, our 10, the standard deviation is larger than it would be if every value was closer to 6. So this is saying if our point 10 did not exist here, well, our mean would be, or it would change our mean. It would turn our mean into 5. But then if our mean was 5, let's take a look at that. 1, 2, 3, 4, 5, 6, 2, 4, 6. If this was our mean, we'd have what? 1 point here, 2 points there, and 1 point there. And you could see how much closer everything is, and it would change our standard deviation. But let's not worry too much about that. Okay. All right. So here we have some practice problems. Let's zoom out so we can get them all on the page. Question 1, which data set has the larger standard deviation, data set A or B? Question 2, true or false? 2 data sets can have the same mean but different standard deviations. Question 3, a class has a very small standard deviation on a test. What does that tell us about the student's test scores? And question 4, is a larger standard deviation always better? Why or why not? Explain. All right, I'll give you a minute to pause here and take a stab at these. All right, hopefully we take a look at them. Let's see the answers. So for the first one, which data set has a larger standard deviation? Data set A, I took the mean and got 20. Data set B, I took the mean and they're both 20. And we observe every point. 10 is 10 away from the mean, 20, 15 is 5 away from the mean, 20 is the mean, 25 is 5 away, and 30 is 10 away. So we have a distance of 5, 10, 0, 5, and 10. I'm going to highlight those. Highlight that in green. And then data set B here, the mean is 20. And here's our distance. Each point is from the mean. 0 is 20 away, 10 is 10 away, 20 is 0 away, 30 is 10 away, and 40 is 20 away. I'll highlight these again over here. Do this one in blue. So we could see for data set B, any given point is further from the mean than data set A. So data set B has a higher standard deviation. We can also show this by graphing. I didn't do that, but that's another way we can go about this. All right, question 2. 2 data sets can have the same mean, but different standard deviations. That is true, and we saw that here with this example. Both of these have the same mean, different standard deviations. 3, a class has a very small standard deviation on the test. What does that tell us about the scores? That tells us the scores are clustered closely to the average. That's all it tells us, okay? And is a larger standard deviation always better? The answer is no. All it means is the data is more spread out. Better or worse is subjective, and we can't definitively say something is better or worse based on looking at the standard deviation. It all depends what the data is and what's being asked of us. Cool. And that's everything I have on standard deviation. In my following videos, I'm going to go into the mathematics behind it so we can better calculate it and understand it. But for this, I just wanted to start with a conceptual understanding. So thank you for tuning in. As always, a link to the notes will be in the video description, and I will see you next time. Take care.